So I'm going to start a new page here. And again, we're just going to write this down because it's important. The probability of A plus the probability of A complement is always going to be 1. So the example we have here is, let's consider the experiment of tossing a coin, okay? So let's say we toss 2 coins. So when 2 coins are tossed, and let's say we have this space. This is our sample space, and event A is a circle in my sample space. And event A is that we get at least 1 head. Okay, so we're flipping coins and we get at least 1 head. That's event A. Okay, so let's list all the ways that we can get at least 1 head when we flip 2 coins. When we do this for 2 coins, we have heads and heads, we have heads and tails, we have tails and heads. These are 3 points in my sample space that fall within A, the circle A. So this is A complement outside here. So there's 1 value in the sample space where no heads are. And that's the complement of at least 1 head would be there are no heads. And that is that we flip a coin twice and we get 2 tails. So this is the only event where this is the only value in my sample space where we are not part of event A. So now, for 2 coins, this is simple. If I want to find the probability of A, it's just 3 out of 4. And that was easy enough. And it was easy enough to list this. But I also could have said, well, let's do 1 minus the probability that I don't flip a coin and get a head. I flip 2 coins and I get no heads. So the probability that I get no heads is 1 out of 4. So this becomes 1 minus 1 out of 4, which is still 3 out of 4. So I can find this probability by brute forcing it and actually doing this all out, or I can find this probability by finding the probability of the complement and then taking that probability and subtracting it from 1. So let's try this again, the same example, except now we're going to flip 10 coins at the same time. Okay, now I knew 2 coins was easy enough because each coin has 2 outcomes. So there's 2 values. Remember our basic counting principles? We have 2 values, and that can happen for each coin. So there's a total of 4, or 2 squared values. So 4 is a manageable set. If I have 10 coins now, each coin, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, could have 2 outcomes. This is 2 to the 10th. 2 to the 10th is 1,024. I do not want to list all of these out, okay? So again, we have the probability, or we have event A here, and event A is getting at least 1 head. Now I could list all of the possibilities out, and just an example of a couple, I'm not going to list them all out, but an example of a couple would be that I get, that's too thin, that I get head, heads, 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 1, 2, 3, 4, 5, 6, 7, 8, 9, and a tails. Okay, so there I got 9 out of 10, and I could, that's one way, but the tails could have been here, could have been here, could have been here, it 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 could have been here. And those are all, even if all 9 of the rest of the flips were heads, there's a spot where tails could be in each of these spots. So that's why there's so many outcomes, because each of those is different. So again, I don't want to list all these out. So it's much easier for me to find a complement. There's only one instance where we don't get at least one head when we flip 10 coins, and that's if 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We flip all tails. So there's only one value here. There's one value out here, and we know that there are 1,024. So if I want to know the probability of A, I'm not going to try to calculate that. Instead, I know that the probability of A complement is going to add up to 1. So if I'm trying to find the probability of A, I'm going to do 1 minus, by subtracting this from both sides of the equation, I'm going to get 1 minus the probability of A complement. So let's find the probability of A complement. A complement is one value out of 1,024. So that means the probability of A is going to be 1,023 out of 1,024. And that was way easier to find than trying to list out every single instance of at least one head and then adding together all of those probabilities. It would just take too long. So the complement helps us in that respect. So we have our unions, which is the joining of two sets, all of the elements in both sets. We have our intersection, which is just the elements that both sets have in common. And then we have our complements, which are all the elements outside of the events that we're interested in, but still within our sample space. All right, I'll see you in the next video.